Okay, in the exciting last video, we actually calculated the forces that we need to do to solve this thing, right? We got a normal force of 17.277, and that's acting into the plane, right? That's the part of gravity that's into the plane, right? 0.2771. That's, since there's no friction on this plane, it's not a player. Now, eventually there will be friction, and that will cause the force of friction to happen. But for now, we're just going to ignore that. It's a frictionless plane, right? See, it just says it right there. So what we really want to worry about is this parallel force, right? That's acting down the plane like this, okay? And that is 12.0976 newtons, right? Now we have 3 sig figs, so I'm carrying 5 sig figs. That should be ample, okay? Now the convention that I always do is I always make up the plane positive, so that makes this solidly a negative force. If it's a frictionless plane, there is, as it slides down the plane, there is no friction force acting up the plane. There's no other force applied to this thing, and so the only force acting, so we're just setting up F equals ma. The only force acting, since it's frictionless, is just that parallel force, minus 12.0976, and then that's going to equal 2.15, and then this is an unknown acceleration problem, right? So let's solve that. Let's see. There we go, divided by 2.15, and I've got 5.627. Yeah, interesting. And that's meters per second squared. And that would be down the plane, right? Okay, so this thing would actually be a 3, I think. Negative 5.63 meters per second down the plane. The reason there's a discrepancy is that I believe back in the day we used 9.80 for these problems when we got the answers. So anyway, there's that. Now just, the problem's over, but let me just show you something that's kind of cool. This force down the plane, the parallel force, right? We have basically negative mg sine theta, right? In this case, that was the only force, right? And that equaled m times a. Notice that the mass cancels here. This is very, very handy because if there's no applied force given to us, right, then these problems are independent of the mass. The rate of acceleration down the plane is just g sine theta, negative g sine theta. In fact, you can just do that right now. I'm going to go negative 9.81 times sine of 35, and I'm getting this exact same answer that I got here. Okay, so that's just handy to know.